So we started class today with this warm-up. So you should take a couple minutes to try the warm-up on your own first. Pause the video, try it, and then play the video to check your answers. So go ahead and do that. Okay, so let me go over number one. We're going to solve and graph on a number line. So let me first get rid of that 1 by subtracting it. Because remember, we're doing reverse order of operations. So we have -3 times the absolute value of 2x minus 7, absolute value greater than or equal to -9. Then I need to get rid of that -3 by dividing. And I have the absolute value of 2x minus 7. Absolute value is, I have to remember to flip the inequality because I divided by a negative, and that equals 3. So now I have the absolute value alone by itself, and it's less than or equal to a positive value, which means I can solve normally. Less than or equal to means one long inequality or two separate ones with the word and. So I'm going to write one long one, 2x minus 7, less than or equal to 3, greater than or equal to -3. So adding 7 gives me 4 is less than or equal to 2x is less than or equal to 10. Dividing everything by 2 gives me 2 is less than or equal to x is less than or equal to 5. So x is greater than or equal to 2 and less than or equal to 5 as one long inequality or two separate ones with the word and. Graphing that on a number line. So I have 2 and 5. Those are closed points. And means shading in between. So the 2 points and shading everything in between. And that takes care of number 1. Number 2 is a piecewise function. So we'll go over that one piece at a time. So I'm going to start with the first equation, y equals -2 times the absolute value of x plus 1 minus 6. So I'm going to substitute in the first value of the domain restriction, so 0. So -2 times 0 plus 1, the absolute value of that, minus 6. So -2 times 0 plus 1 is 1. The absolute value of 1 is 1. So 1 times -2 is -2 minus 6, which is -8. So that gives me the coordinate point 0, -8. Because 0, -8, because I have a less than symbol and not equal, I'm going to go to the point 0, -8, and I'm going to plot an open point at 0, -8. So now I'm going to graph the rest of this absolute value, and I'm looking at the inequality to decide which side, left or right. I see less than we know means to the left. So I'm going to be graphing every point of the absolute value equation, its graph. I'm going to be graphing every point that's to the left of the point I currently have plotted. So I'm going to see where the vertex would be, and I'll see if that's to the left of the point I already have. So looking at the equation, I know that adding 1 is a left 1 shift, and minus 6 is a down shift. So from 0, 0, if I go left 1 and down 6, that takes me to -1, -6, and I'm looking, is -1, -6 to the left of the point I already have plotted? Yes, it is. So I am going to go ahead and plot the vertex at -1, -6. So that's the vertex. So I can go ahead and connect those two, that open point to the vertex. And then from the vertex, I know I need everything to the left, so I need the rest of the absolute value graph, which would be the whole left side of the absolute value. So I'm going to use this kind of like slope, the -2, -2 over 1. So I'm going to go down 2 from that point and left 1. And I'm going to do that a few times. And then I will go ahead and graph the absolute value. So that's the first piece of the piecewise function. Okay, next we need to graph y equals 5. Well, y equals 5 would be a straight horizontal line, but there are some domain restrictions here. So I'm going to start this horizontal line at y equals 5, but I'm going to start it at x equals 0. So 0, 5, I'm going to put a closed point because of the equal sign. And 4, 5, I'm going to put an open point because of the not equal sign. And then I know that I'm going to connect those because it says, the domain says all values between x equals 0 and 4. So that's why I'm shading that there at 5. So we have y equals 5 starting at 0 and ending at 4 for x. So that's the second piece. The third piece is another equation, linear, y equals 2x plus 1. So I'll go ahead and substitute 4 in for x, which gives me 8 plus 1, which gives me 9. So the coordinate point is, I don't know why that doesn't want to write, 9. So our coordinate point is 4, 9. So at 4, 9, I'm going to put a closed point, closed because of the equal sign, at 4, 9. 4, 9, right there. So I'm looking at the inequality. Greater than tells me to the right. So I want to graph to the right of that point, and I'm going to use my slope to do it. So m, my slope is 2 over 1. So I'm rising 2 and to the right 1. And I'm double checking that. If I start at that point and I rise 2 and I run 1 to the right, am I going in the correct direction? Yes, I am, because I wanted to be going in the right direction. So from that point, I'm rising 2 about right there and running 1 there. And I can do that a couple times. And then I'm going to graph that line. Okay. So that is our piecewise function. Number 2, part B. So I'm supposed to evaluate f of 0, meaning I'm going to start by inputting 0 into the f function, which is the one we just graphed. So if I input 0 into the f function, I'm looking, is 0 less than 0, equal to 0, or greater than 4? Well, we know it's equal to 0. So that means our output for the f of 0 is 5. So now I'm going to input 5 into f again. So I'm going to find f of 5. And when I do that, I'm going here and I'm looking and I'm seeing that 5 is greater than 4. So that means I'm inputting into the bottom equation. So f of 5 is equal to 2 times 5 plus 1, which is 10 plus 1, which is 11. So my final answer for f of 0 is equal to 11. That takes care of the warm-up. The rest of class today was just time for practice and working on these pages and these problems on these pages. And it was just an opportunity to ask questions to get ready for Thursday and Friday's test. So you want to do pages 41, 2, and 3, 38 and 28, and all the problems on those pages. And whatever you don't finish, you want to finish up for homework due tomorrow. And make sure if you have any questions or need any help to come see me. But that was the assignment. Like I said, we worked on that in class, and then students were supposed to finish those up for homework.